Speaker. Okay, welcome you all for this wonderful session. Okay, so today in this session we have see about the EV. So EV design. So why we can use EV and the vehicle dynamics of EV. And so there is time is battery. Okay, so these are all concept you can see in these topics. So today topics. So before going to EV, you want to know about why need EV. Okay, so any one person comment in box why you need the EV. Git wallets, so right. So tackle the environmental pollutions. So any other person can you tell why you gonna need to go EV? Yeah, environmental pollution is right. That's correct. Other reasons, promote testability. Okay, EVs are very efficient. Yes, complexity of IC engine, not complexity of IC engines. No, no, that is not a reason. Yeah. So the main thing is there are two main things. So one is green effects of environment. Okay, there is a large pollutions due to carbon emission NOx by using IC engines. Okay, so we have to move to the next mobility. So next mobility means without pollution means it's a EV. Okay, so we can using the EV. So EVs also have some challenges. Okay, so today this is 1 hour. We have to focus the why we need use the EV. What are the challenges in the EV? What are the types of in EV, and how to design a EV. Okay, so this concept are we can see in today topics. Okay, So electric vehicle. So electric vehicle is nothing but carried out by the propulsion by using the electric motors. Okay. So we run the electric motor means we need the energy. So where we get the energy from? Battery called a electric vehicle. Okay. So electric vehicle nothing but in a vehicle driven by the motor. Okay. When the motor driven by using the battery. Okay. It's called electric vehicle. So apart from the battery, some alternate sources are also available in the electric propulsions. So the examples are solar panel, fuel cells, and electric generator. Okay, so by using this alternate energy source, by drive the vehicle. So ultimate aim is we can drive the vehicle by using the any energy resource sources. Okay, so what are the sources means? So solar panels, fuel cells, so electric generator. These are all the energy sources to drive the electricity. Okay, so why we need the electric vehicles? So electric vehicles are very low noise and less vibration. Okay, why means you have the less number of moving parts. Means compared to IC engines. So in IC engines, they need the thousand plus components to make the one engine. Okay, so compared to IC engine means so IC engine making component means we have the thousand plus components. Okay, but here we can compare to IC engine very less number of moving parts. So that's why there is no noise and vibrations. Okay, so carbon emission is very less compared to conventional vehicles. Why when compare like that means in manufacturing, so manufacturing of lithium-ion battery is a most carbon emission. Okay, the manufacture of lithium-ion battery means is a most carbon emissions, but when you're driving means there is no emissions. So that's why you can compare with the IC engines. So these comparatives are compared to only IC engines only. Okay, so reduce the deficiency of oil because the fossil fuels not visible in future. Okay, here we can use the comparison. So no tap tail emission. So no tap tail emission means there is no emission while driving the vehicle. Okay, so next is greenhouse. When using IC engine means greenhouse gases effect and pollution. So utility company. So when charge the battery using electricity, we can generate the electricity by using some sources. So utility company OPC. So operational petroleum company corporation. We have to buy the fossil fuels to split the petrol, diesel, kerosene, whatever. So nowadays we can using the in India nowadays we can use the 300 plus mile range. Okay, in EV. So in IC is also near to IC is also 300 plus drive range. So hours to recharge maybe take time. Okay, so what in IC engine fuel time is very less. You can give the amount for 100 rupees, please. You can refuel the in 10 minutes. So within 10 minutes you can refuel the fuel, but battery recharge hours taking near 6 to 8 hours. Okay, so flash charge also available. That also taking some time. Here the mileage 2 centimeter per mile, 12 centimeters per mile. Okay, so this is a comparison of electric vehicles. So why we need to go to the electric vehicles? So next is a short form of EV. So EV is the short and acronym. So the full name is electric vehicle. This vehicle are driven by partially or fully powered by the electric power. Okay, so electric vehicles have a low number of moving parts. So maintaining is also very easy. So environment friendly. So there is no need of fossil fuels. Okay, so while some EV use as a lead acid or nickel metal hydride, so nowadays we can use the standard modern battery lithium ion. So in future we can use the phosphorus batteries. So ferrous phosphate batteries. Also, so some vehicles nowadays some vehicles using the ferrous phosphate battery, but it is the how to develop EV. So in ancient days we can use only lead acid. So after that using the nickel metal hydride batteries. So and lithium ion in future ferrous phosphate. So these are comparison with the batteries. Okay, long lasting batteries. So history. So now we can see the history of electric vehicle. So last 100 years in India we can use the IC engines. So in internal combustion engine. That's why the electric vehicle full need concepts. But the fact is different. So in 1980s, in 1990s, so electric taxi floods in New York. Okay. So the one more interesting fact is electric vehicle held in the world road speed record is 1000 sorry 105 plus 9 kilometer per hour. This is the first EV. Okay, so first EV speed record is 100 kilometer per hour. Okay, so this is the vehicle. So here we can cross the 100 plus mile range in 1899. The name of the car is La Jamsis Content. La Jamsis Content. So driver name is Cambly Density. So driver name is Cambly Density. So in 1830, so electric garage was powered by the rechargeable batteries. Okay, in 1830s, so electric vehicle garage built by the powered by the rechargeable batteries. In 1890, William Morrison assembled the first electric autonomous vehicle in US. Okay, in 1990s, so 28 percentage of car we have produced electric drivetrain in United States in US, not in India, in US. Okay, so expert India, all the testing is going under the electric vehicles. Okay, in 90s. Okay, so mid of 1970, city car was built by the Vanguard Cybertruck. So this vehicle has a 32 mile per hour with the speed of top speed of 40-mile range. Okay, so this car based on the MG Hector. So nowadays we can use the MG Hector city car, small model. So like that, Vanguard Cybertruck is developed in 1970. So electric vehicle. Okay, so in 1990, General Motors introduced the electric vehicle named EV1. So 1997, Toyota Prius. That is the first electrical vehicle commercially used in the mass production. So on four members, so real IC engines car model. So IC engines cars model in 1997, Toyota Prius launched in this car. Okay, so commercial four members driving car. So in 2080, so directly in 2080, so Tesla launched the battery sports vehicle in the Tesla Roadster. Okay, so Toyota Prius is in 1997, but Tesla car is 2008. So here the first racing car by in electric vehicle. Okay, so nowadays also the first electrical vehicle in car company means Tesla. So after that the Rolls Royals, Mercedes Benz. Okay, lots of vehicle Jaguar is coming, but first electrical top companies. So top companies. So number one is Tesla. Okay, till now also. So benefits of electric vehicle. So what are the benefits means? So energy efficiency is very higher compared to IC engines. So electric cars are reduce the emissions. There is no emission, so that should mean the reduce emissions. So fuel cost propulsion is very less. Okay, so fuel cost propulsion is very less. Drive system is very simpler. Okay, so drive system, so simple drive system. There is no complexity of drive system, simple drive system. Motor if you want to use means gearbox. So gearbox to differential unit. So differential unit to tire. So the propulsion is very simple. There is no gearbox means you can use the simple gear concept. So forward and reverse. Okay. So some companies so differential unit to tire. So driving system is very simple. While using the EV means they will generate the regenerative braking. Okay, so regenerative braking nothing but so generate the power while rotating the wheel in free manner. That time the voltage will be generate. That voltage stored in the stored in the battery. Okay, so challenges. So that are benefits. So now choose the challenges. So what are the challenges occur means? So range of the electric vehicle is very less compared to IC engine. Okay, so refueling time is take more than two IC engine. Okay, refueling so take the more than two IC engines. The cost of the electric vehicle is more expensive than conventional vehicle. Okay, because of the major parts of the EVs. So what are all the major parts in EV? If you know means so comment in comment box. So what are all the major components using in the EV? Important components. Important components. Yeah, please, anyone comment in comment box what are all the important components needed to drive the EV vehicle. So chat in chat box. Yeah, motor, clutch, differential, torque, converter, battery, gearbox. Yeah, unbrand, unbrand to top. Yes, motor, clutch, different. So how we can split test means, so first need is motor. Okay, so while driving the motor means we need the power. So power we can get from the battery. So compared to IC engine means, so IC engine we can use the fuel. So instead of fuel we can use the battery. So fuel going to the engine. So engine generate the power. So here we can use the motor. Okay. So battery motor only couple means only driving, but you have to control. So control means you need a controller. Okay, so the main components of EV means battery, motor, controller. Okay, so three important thing is this only. So after that, these are the parts. So clutch, differential unit, so converter, battery. So that's all secondary battery. So major components. So in interview questions, what are all the major components using in EV means battery, motor, controller. Okay, these are all the main things. So energy resources. So we have to drive the electric vehicle in electric vehicle. So where we can get the electrical source. So these are all the sources. Okay, so when speak about the renewable energy means these are all the renewable energy. So all guys you all know about the solar energy. So solar energy is nothing but, so all of you know, so generate the source from the sun. Okay, solar energy. Wind energy also you have to know. So using fan, we can generate the power. Okay, so wind energy. Hydro energy means taking the power from the dam. So dam, or we can take the power from hydropower plant. Tidal energy, biomass energy, nuclear energy. So nuclear energy means not in use nowadays, but biomass energy, tidal energy is very less. So tidal energy is nothing but when in a room, when water strike on the wall, so the strike, based on the strike, the electricity power will be generated. So called tidal energy. So biomass energy means we can dump the wastage into one dump, so closed. So after some years we can the gas will be generated. So the gas converted into electrical energy. So that is a biomass energy. So nuclear energy means we are using only generate for power, but not in EV vehicle. But that also an energy source. Okay, to generate the electricity. So these sources are used for generating the electricity. Okay, so very important topic. So types of electric vehicle. So nowadays, so the market using the this technology only. Okay, so based on the energy conditions, so electric was cast into four types. The only four types in market. So commercial vehicle or developed vehicle, whatever. So only 4 types only available in the market. So first one is BEV. So pure electric vehicle. Here battery BEV. So pure electric vehicle. So the name is called, another name, pure electric vehicle. So why we can call it means I explain in the next slide. So next one is hybrid electric vehicle. So hybrid means you have to, you all of know. So combination of two sources. Okay, so combination of two or more sources called IC engine. So here we can use the IC engines. Okay, here we can use the IC engines and motor also. So energy is a tank and battery. So plug-in. So plug-in hybrid means so electric vehicle is so I can see also next slide. So same similar, but the comparison very high. I can show the comparison. So next is fuel cell. Okay, so these are the types only in market available types. So electric vehicle categories into only 4 types. So BEV, HEV, PHEV, FEV. Okay, this only the types in electric vehicles. Okay, so battery electric vehicles. So BEV. So electric vehicles within only the battery say energy sources. So BEV means is called a pure EV. So only energy sources to run the drivetrain is called a battery. Okay, so it's a BEV. The range of the vehicle is directly proportional to the battery capacity. Okay, so the common BEV drive range is now 300 to 400 kilometer. So nowadays, so charging time is directly depending upon the operating power level of an infrastructure. Okay, so the main BEV means so range and the charging capacity is directly proportional to the battery capacity. Okay, because of only we drive the vehicle by only the battery. Okay, so drive the electric motor by using the battery. Okay, there is no another any resources to drive the vehicle. So hybrid electric vehicle. So for propulsion, hybrid vehicles use the both IC engines and battery pack. So for example, we can give the IC engine and battery pack. So if you also use the CNG or any other source means that also we can make combined. But here the example we can see the both IC engine and battery pack. Okay, so when first one new technology introduced to the market means so use only hybrid method because of an large number of people using the old method. So we have to combine the new method means so first you have to add the small amount of new technology. That means so when capacity fuel tank capacity is very high but battery capacity is very less. Okay, for to go to the when fuel is empty means you have to go to the bulk, so use the primary source. So here we can split into primary and secondary. Okay, here the IC engine is the primary. So hybrid electric vehicle means primary is IC engine, secondary is battery EV. Okay, so during low speed I use the electric vehicle, during high speed I use the IC engines. Okay, by control by using the switches. Okay, nowadays also we can use the CNG plus petrol variant. That means we can drive the petrol. So if you want to press the switches, so convert into CNG. Okay, some Suzuki Ertiga. So many other car models have. So just example like in the Maruti Suzuki Ertiga also that use the CNG variant car. So that example means we can use the petrol and CNG in both in one single vehicle. So same concept we can testing the IC engine and BEV. Okay, so it is hybrid electric vehicle. So in hybrid electric vehicle, we can have the power boost when require the boost of gear shift. So IC engine also can have the charging capability while driving because of IC engine and motor are coupled in single drive shaft. When the engine rotate means motor will be rotated. That time the motor will be rotating empty. Okay, empty means rotating. That time the voltage will be generated, back EMF. So the name called back EMF. So the voltage is generated. So that voltage we can stored in the battery. So called regenerative braking system. So this is a concept, but we can testing the real time. But the real time is still not proven. Okay, so motor generate the voltage. That voltage does not much to charge the battery. Okay, so motor only generate the 3 to 4 volt, but the battery capacity is more than 12 volt. Okay, so there is no need of that voltage, no need of generating voltage, but the concept is while motor running in empty condition or unload condition, so some voltage will be generated, so that voltage charge to the battery. So that is a concept. Okay, so that's called hydrogen brake system. So the primary energy source of the drivetrain is IC engine. So I already told. So primary energy is IC engine. So secondary storage is BEV. So electric vehicle. Okay, so plug-in hybrid vehicle. So plug-in vehicle is also similar to the hybrid. So the variation is IC is a secondary engine. Battery EV is the main, so primary engine, primary source, not engine, primary source. So we are using the battery capacity. So increase the battery capacity and increase the battery capacity and compared to the IC engines. Okay, so less fuel tank. So for example, increase 80 kilowatt battery. So fuel tank is only 5 liter. So that time maximum usage of electric vehicle. So minimum usage of IC engine. So that's called a plug-in hybrid electric vehicle. So the carbon emission of PHEV is very less compared to hybrid electric vehicle. So because of we can use the more time. So more time battery vehicle. So there is no carbon emissions. So compared to hybrid electric vehicle. Okay. So next one is a fuel cell electric vehicle. So this is the pure without a carbon emission vehicle. Why means, so fuel cell produced by use of chemical reaction without any combustion. We can just make the chemical reaction and to generate the electricity. So this is the pure carbon emission vehicle. Okay, so I just explain the working of fuel cell. So the fuel cell used the hydrogen and the oxygen, so byproduct reaction of water. Okay, so in the electric vehicle we can fit the two cylinders, so hydrogen and the oxygen cylinder. So we can just react. So we can just react the two hydrogen and oxygen, so H2 and O2. We can get the byproduct of O2. So that time, so chemical reaction occurs. So oxygen and oxygen to chemical reaction occurs. That time the energy will be created. That energy we can store in the battery. So we can store in the battery. So from the battery we can give the power to electric motor to drive the vehicle. Okay. So for energy storage we can use the battery or super capacitors. Okay. So energy comes from the fuel cell electric vehicle. So from the fuel cell. Okay, so there is no carbon emission in fuel cell electric vehicle. Okay, so fuel cell we cannot use in car, but in Ashok Leyland launched in London. Ashok Leyland launched in London the fuel cell bus. Okay, so after you complete the class, you guys are checking the bus. So fuel bus is available in London. So not used in India, but the fuel cell vehicle is used in London. Okay, in India now only we can use the electric vehicle. So one by one electric vehicles are increased in the market. So in as soon as possible the fuel cell also launched in market. But here there is no, in India there is no fuel cell, but in London fuel cell bus is available. You can after the completion class you can check in online. Okay, so next drivetrain configuration. Okay, so drivetrain configuration is nothing but so how we can connect the components motor, clutch, gearbox and differential. Okay, so this is a common connection. So first one is a common connection, motor to clutch plate, so to gearbox to drivetrain, so drivetrain to wheel while drive the vehicle. Okay, without clutch and gearbox means we can use the simple gear. So here the simple gear. Why we can use simple gear means we want to move the vehicle front and back. Okay, so that time we need the simple gear concept. So motor, simple gear and drivetrain. Okay, so these are the connections. Okay, so many of members use the motor, simple gear and the gearbox to develop the vehicle. Okay, so without gearbox we can use the parallel circuit. Okay, so these are the series connections. These are the parallel connections. So when connect the parallel sufficient means we can get the more power. So these are more power because of when electrical and differential connected in parallel manner. Okay, so motor, simple gear, differential unit, so connect in same line, so get the more power. Okay, this one concept. So combination of two motors. Okay, so split motors, so one motor to right wheel, one motor to left wheel to control the vehicle. So in Nissan launches the this type of motor vehicle. So it is a usage of you can turn your car in single room. Okay, when the two wheels rotate opposite direction, vehicle will be drifted, turn into 360 degree. Okay, Nissan launched the car in China. Okay, here it not use the two wheels motor. So this specification of generate the more power. Okay, so when load vehicle we can use the separate motor to the wheel means we can get the more power. Okay, more power and also very reliability. We can turning the car in a single room. So getting the 360 degree. Okay, these are all the connections. So parallel series connections, and the combination of two motors. Okay, so introduction of EVs. That's all. If you have any doubt, means you have to ask. I clarify it, and next we can go to the next topic. Okay, so ask any doubt. We move. There is no doubt means we have to move the next session. Okay, these are all the concept about the EV, introduction of EV. So in introduction of EV, you have guys have any doubt means so feel free to ask. We have to move to next session. The Anusma Basmati in fuel cell means hydrogen and oxygen. Okay, now one cylinder is a working of fuel cell is nothing but so one cylinder of oxygen, one cylinder of oxygen. Okay, hydrogen and oxygen H2 and O2. We have to combine in single. Okay, so oxygen cylinder from hydrogen cylinder we have to one chamber. That chamber we have to supply the both gases. Okay, hydrogen gas and oxygen gas. So supply into the box means that time chemical reaction will be occur. Okay, when a chemical reaction will occur means some energy will be created. Okay, so that energy stored in the battery. So we can drive the vehicle. So that time the chemical reaction occur means some byproduct will be generated. So that is H2O. So the H2O is used for cooling purposes. Okay. So fuel means hydrogen and oxygen is the fuel. Gases, not in liquid manner, gas. So any other doubts? Any other doubts? So there is no doubt means you have to move to next topics. There is no doubt. We move to the next topics, vehicle dynamics. Okay. So before going to manifest the EV, we have to satisfy the vehicle dynamics. So in ICE engine also this topic is available. So for to go to design, so this is your first step for ICE engines also and EV also. Okay, so formulas will be very, so this is the analytical method. Okay, derive and the calculation method. So these are the mathematical orientation. Okay, so for design of electric vehicles. So design of electric vehicle. So this is a first topic. So EV introduction. So before going to design, we have to know about the topics. Okay. So any example like pen means we have to know why we can need the pen. What are the uses of pen? We have to know. So that is we can introduce the EV introduction. So this is first part. So design of electric vehicle means this is very important topic. So vehicle dynamics. Okay, so vehicle dynamics is nothing but so how much power required to move your vehicle from zero position to some speed. Okay, so according to the Newton's law of mechanisms, so the vehicle dynamics is working. Okay, the simple concept, so simply says means how much power required to move your vehicle to from zero position. Because of when vehicle in zero position, we have to move the vehicle to some speed. So how much power required to move your vehicle? Okay, so based on the power we have to choose the motor. So based on the motor power we have to choose the battery and the controller. Okay, so that's why I am telling this is the important topic of EV. Okay, because of you have to choose the motor, battery, controller. So these three things. So depend upon the three things you have to choose the converter, inverter, so charging capability, voltage, current, so whatever. So depend upon these three topics you have to choose the another topics. Okay, so this is very important. Okay, so vehicle emission simply says means how much power required to move your vehicle from to some speed, zero to some speed. Okay, so force acting on the vehicle. So the totally name is called total tractive force. So TTF. So we have TTF classified into four types. Okay, so these are all the forces acting along your vehicle while driving. These are all the forces acting along the vehicle. So rolling resistance force, aerodynamic drag force, gradient resistance, and acceleration force. So acceleration force is linear acceleration and angular acceleration. So acceleration category is two types. So linear and angular. Okay, these are all forces acting along your vehicle. Okay, so first one is rolling resistance. Okay, so rolling resistance is nothing but when a tire reach on the ground. Okay, so the hard surfaces caused by the ices on tire materials. So ices causes the asymmetric distribution of ground reaction forces. Okay, so that time, so in tire we have to acting the two forces. So one is normal force. Here the normal force is nothing but gravitational force. One is traction force. When tire is rotating, so opposite forces will affect your tires. Okay, so these two forces acting along the tire. Okay, because of when your vehicle tire is touch the ground, so tire will be generate the power. So rotate. So we have this considered. So where will be get from the formula? So the phenomenon result of shifting the ground reaction force. So P equal to M into G. So M is nothing but mass of the vehicle. G is the gravity force. Okay. So rolling resistance moment is nothing but P into A. Okay. So rolling resistance moment is P equal to A. So we have already know P equal to M into G. Okay. So the force required to keep rolling means F equal to TR by RD. So we have already know TR equal to P into A. So now substitute instead of TR P into A by RD. So here the RD is the rolling resistance. So I take the RD in outside. So the formula converted into P into FR. Okay. So have to already know P equal to M into G. So P into FR we already know P equal to M into G. So that time we can substitute the formula M into G into FR. Here the FR is nothing but coefficient. Okay, so FR is nothing but tire coefficient. So see in the next one, what is meant by coefficient? So coefficient is nothing but so values so generated by the tire materials. So it is one of the forces acting opposed the motion of vehicle. Okay, the coefficient function is generated from the tire material structure, temperature, pressure, thread geometry, material pressures, and absence of liquid on the road. Okay, so that time this is a coefficient value. You have to design the vehicle means you have to choose the coefficient values from online also. So some data I can give. So the data also get from the Google only. Okay, so the data is feed by the tire company. So manufacturer tire company, they give the coefficient value. So based on how we can give this based on these parameters, tire material, structure, temperature, pressure. Based upon the this value, so tire manufacturer company give the values. These values vary with the speed. The pressure increases, value will be decreases. Okay, so these are the coefficient values. So this coefficient value you can use to get the value. So tire on concrete or asphalt means you can use the 0.013. So your car run in road gravel means 0.02. So where rail in car in travel in rail means you can use the 0.012, 0.02. Okay, these are all the coefficient value we can use. So mass into gravity into FR. This is a rolling resistance formula. Okay, so next one is aerodynamic drag. Because of when a vehicle moves in air medium. Okay, the force encounter the motions, so referred to as a aerodynamic drag. So it classified into two forms: shape drag and skin friction. Okay, so shape drag is nothing but so when in this area, when a vehicle moves in air medium means in this area it is a high pressure area. Okay, we give to the shape to the car. So that time what will happen means high pressure air flows to the low pressure area because of here the low pressure area. Okay, when air medium strike on the this area, so generate high pressure. The high pressure so transfer to the low pressure area. Okay, so the it will be neglected. So now we are considered as the skin friction only because of when air vehicle produce the frictions on the screen of the car. Okay, just that's only now considered. So half into rho into CD into A into V square. So half multiply rho multiply CD multiply A multiply into V square. Okay, so one by one we can see. So rho is air density kg per meter cube. Because of in south of Tamil Nadu, we can use the 1.250 is the air density. In north side, value will be vary. In London, value will be vary. In China, value air density will be vary. So as a designer, so which country how to design the car? So that country what have the air density? So that air density value you have to just consider. Okay. So front area. So what is your designed vehicle front area? That value you have to put. Okay. So what is the frontal area of your designed car? So drag coefficient. Okay, here also have the drag coefficient. So in next slide I have show the drag coefficient. So finally is the velocity of vehicle. You have to substitute in meter per second. Okay, so because of in this unit you have to substitute. Okay, because of force unit Newton, we have the data in Newton. You get the data in Newton means you have to substitute the value in kg per meter cube, meter square, and meter per second. Okay, you have to substitute in mm square means it converted to joule. You have to substitute kilometer per hour means it converted to work done in joule seconds. So, but you have need to Newton. Okay, you get the Newton means you have to substitute in parameters in this unit like meter per second, meter square, kg per meter cube. Okay, so next is drag coefficient. Okay, drag coefficient. So how we can take the graph coefficient means shape of your front. So front shape of your front glasses. Okay, it will be straight means drag coefficient very high. So when drag coefficient very angled means it R will be very less. Okay, so this is a coefficient values. So see this car. So this is in flat face. So coefficient value is 0.85. So compared to this, it will be lightly slope. So the CD value is 0.50. So compared to this is more slope. So why means, so when a car run in air medium, so when strike the air, so high pressure will be generated. So that high pressure we want to move to backside in this slope. Okay, so that time it will be, yeah, so high pressure area goes to this area, so vehicle in drive fastly. So this is a coefficient of aerodynamic drag. So in rolling resistance, that one in hard values. So but here we can use the coefficient here. Okay, so some another examples coefficient values. So trucks, so 0.8215, buses 0.6, 0.7, so motorcycles 0.62, 0.7. So these are the coefficient values. Okay, so gradient resistance are hill climbing force. Okay, when a vehicle goes up or down a slope, okay, so always weight is produced in a downward direction. When a vehicle in upslope or downslope, but the weight of the vehicle is acting always in a downward direction. Okay, but the third force act along the vehicle in a gradient force. Okay, occurs when vehicle driving in upward or downward. Okay, when vehicle upward down means the force will acting in a downward direction. So one force acting in a downward direction. So gravitational force opposite to downward direction. So one force in inclined direction. So we have the one law of mechanics. Okay, so law of mechanics, when a force acting in a inclination direction, we have to split in two direction, horizontal and vertical. One force acting in one inclination means we have to split in horizontal and vertical. So like that. So mg cos theta, mg sin theta. So here the gravitational force and the forward direction means is opposites. So it will be 0. Okay, just we can consider the this force only. So m into g into sin theta. So m into g into sin theta. Here the height is how much slope when car you will travel. So here the theta slope value. Just to consider the sin theta here. Okay. So this is the formula of gradient resistance. So rolling resistance formula is m into g into fr. So gradient resistance formula means m into g into sin theta. Aerodynamic drag force is half into rho into cd into a into v square. Okay, so this gradation is not necessary to generate formula when a vehicle drives in hill station. Okay, when your vehicle, when your descent vehicle drive in hill station means you have to consider as the gradient resistance. So otherwise, when a vehicle drive in linear direction only means, so no need of no consider of gradient resistance. Okay. So we have now to find the total tractive power. So P equal to F into V. So that is nothing but so total tractive force into velocity. So what is the total tractive force means? So sum of the forces. So sum of the forces means rolling resistance, aerodynamic drag, and gradient resistance and acceleration force. Okay. So we can sum of these forces. We can get the total tractive force. So total tractive force into velocity to get the power. Okay, so now next you see the acceleration force. So due to continuous changing of the velocity with respect to time, so acceleration also changes because of a vehicle driving not in same speed. At city you have to change the speed. At outstation also in a highway also change the speed. Sometimes you could travel in 100, so sometimes traveling in 60 or 50. Okay, because why you can tell means so acceleration will be not constant. It may be vary. Okay, at high acceleration will be need more. At low acceleration will be need less. Okay, so the acceleration formula. So from the second law of motion, so acceleration formula means F equal to m into a. F equal to m into a. Okay, just we can substitute the m into a. We can consider the acceleration means we have to derivative by the dv by dt. So dv by dt means with related to the time, with respect to time. So the energy computed motion is integration of energy equal to integral of p total attractive force into dt. You have to find the energy. So if you want to find the energy means the formula is integral of p track into dt. So total power attractive force into time. Okay. So here the acceleration formula. So linear acceleration. So F equal to m into a. You have the vehicle only two forces means you can just go with the acceleration forces. But you have to consider the gradient ratios means you have to go with the angular acceleration forces. Okay. So angular acceleration force formula means Ig square a by r square into nq. So I is the moment of inertia, g is the gear ratio of your vehicle. So a is the acceleration force. So r is the radius of your tire. Nq is the efficiency of gearbox. Not nq is the efficiency of gearbox, not your gear efficiency of gearbox. So what type of gearbox you can choose means, and in data sheet efficiency also mentioned. So you have just take the value from the gearbox efficiency. Okay, so radius of the tire means what type of tire we can use to put the radius. So gear ratio of your gearbox. So moment of inertia get from the areas. So moment of inertia get from the area. Okay, so 5 to 10 percentage of linear acceleration will be the angular acceleration. So the vehicle driven by the motor power through the gear means you can use this formula P equal to T into omega. Okay, so the speed of the vehicle, how to calculate the omega means, so velocity by radius of the wheel into gear ratio. Okay, so here the T is torque, but omega, how to find the omega means omega equal to velocity by radius of the wheel into gear ratio. Okay, so now the formula how to convert means T into V by velocity by radius of the wheel into gear ratio. Okay, when a motor driven by the gearbox. Okay, we can use the gearbox means we have to use this formula. So we have to find the critical velocity by using above equations. We have to some programs in MATLAB we substitute, we can find the critical velocity. So critical velocity means how much time take your vehicle to reach your speed. For example, you fix the vehicle in 40 kilometer per hour. So when 0 to 40 kilometer per hour, how much time it will be take? Okay, so we can execute in MATLAB. Okay, so any doubts? So regarding vehicle dynamics, any doubt? In vehicle dynamics topics, if you have any doubt means please ask. Next I will go to the example sum. In example sum we have to better to understand the concept. Okay, I just explain the formula manner, and example sums also available. So that time understand very easily. So before going to example sum, you have to know our concept who understand. So any doubt means, so chat in chat box. I will clear that. So this is very important topic. Chaudhary, you have to ask the doubt in vehicle dynamics. I will clarify the doubt in charging after that. So now see the vehicle dynamics topic only. So in vehicle dynamics topics, you have any doubt means, so please ask. I have clarified. No doubt, no doubt in concept. We have to move to the example sums in vehicle dynamics. Yeah, okay. So relative vehicle dynamics calculations. So here the data. Okay, so here the data. So these data are real data. So we have to develop in EV in R&D. So from R&D, so we have to collect the data. So what is the weight of your vehicle? So length, width, air density. So these are real time data we have chosen. Okay, so in Pantech YouTube channel, that vehicle running video also available. You can please check. So for the vehicle, this is a real-time calculations. So we have considered the total weight of the vehicle is 280 kg. So width of the vehicle is 705 mm. So height of the vehicle is 1080 mm. Length of the vehicle is 1950 mm. Okay. So we have considered width. So FR, we have choose the FR coefficient, aerodynamic coefficient. So in South India, air density is 1250 kg per meter cube. So CD, so aerodynamic coefficient 0.30. So from the width and height considered, we can get the area value. So gravity, so already you know gravity 9.81. So angle inclination is 6 degree. So tire radius is 0.3. So velocity is 90 km per hour. Okay. So when the maximum speed is 90 km per hour. So this is the data. So from this data, I want to calculate how much power required to move your vehicle to 0 to 90 km per hour. Okay. So first step is we have to know. So power equal to velocity into for the basic formula. So power equal to velocity into force. So force equal to power by velocity. So now we have to know the power. So power means total tractive force into velocity. So what is the total tractive force means sum of aerodynamic force, rolling resistance and gradient resistance. So I already know the aerodynamic drag force. So half into rho into CD into A into V square. Okay, here the half into 0.5. So rho equal to 1.250, CD equal to 0.3. So A equal to 0.761. So V square, because of in V kilometer per hour, I want to convert into meter per second. So kilometer to meter. So I just consider the kilo thousand. So 90 into 1000. So next is hour. So hour to minutes 160. So minutes to seconds 160. So 60 cross 60 is 3600 seconds. So whole square I can put. So now simplify. So now simplify this, multiply these values. I get 0.142. So here I simplify. So 90 into 1000, 9000. So I have to simplify 2020. So we have the value means 90 by 10 by 30, sorry, simplify 90. So 1000, 2020, 10 by 36. So 10 by 36 means 3.6. Okay, so 90 by 3.6. So 0.412 into 625. We can simplify means you can get the 625. Okay, so the FD value means 89.17 Newton. The what is the 89 value means for this data I want the force, so 890 Newton. When a vehicle I want to move your vehicle 0 to some speed means the required force is 90 Newton. Okay, that is a concept. So another method, aptitude method. So another aptitude method of the conversion of kilometer per hour to meter per second, 5 by 18. You can put the 5 by 18 into 90. Okay, so otherwise 90 into 5 by 18 means, so 90 into 5 by 18 means you have to easily find the meter per second. Okay, this also use that values also we can use. So nothing to worry. So two methods are correct. We have to find the correct value. That's all. Okay. As a design engineer, you have to give the current data means from the current data they have to purchase the components. Okay. So full responsibility how to choose the values in correct ways. That's all. Okay. So 90 Newton required to move your vehicle. So next is rolling resistance. So rolling resistance formula I know M into G into F R. Okay. So I know the mass of the vehicle 280 into G equal to 9.81. So FR equal to 0.013. Okay. So gradient resistance is M into G into sin theta. So M equal to 280, G equal to 9.81. So here the sin theta we cannot substitute directly in sin theta. We have to convert the value degree to radian. How to convert the degree to radian means pi by 180. Okay, so convert the pi by 180. So 6 into pi by 180, you get the radian value. So how to find the first radian value? So sine radian value. After that, you can multiply with 9.8 on the 280. That only you can get this value. You put the directly 280 9.1 sine 6 means answer will be vary. Okay, another time you can tell. So first sine theta means when the degree. So how to degree convert into radian. Okay, one value will become. So for the radian, so sine radian value. So after that you can find 9.8 on the 280. That answer will be correct. Otherwise answer will be wrong. Okay, so now I find the total tractive force. Okay, so 89.179. So 35 point. So sum of this forces. Okay, I want to sum of these forces. So I sum of these forces means I can get the 4112 Newton. So our total tractive force is 4112 Newton. So now I get the power. Okay, so power means TTF into V. So 404 TTF 412 into 0.06. So 90 by 3.6. Okay, so 1030 560 watts. Okay, just I convert into kilowatt. Okay, in market you have to buy the products in kilowatt, so that's why I convert into kilowatt divided by 1000. We convert the kilowatts divided by 1000, so power equal to 1.30 kilowatt. So power equal to 1.030 kilowatt. Okay, now we select the motor for 1200 watts BLDC or up motor. So we have to use up motor means 1200 up motor. Otherwise you can choose the motor. So what is the concept means how much power required you can choose more than. Okay, for example 1.5 means you have to go to 2 kilowatt motor. Okay, that is very important. So I get the power is 1 kilowatt. So I go with the next values was 1200 watts. Okay, now we can design the motor of 1.2 kilowatt power of battery and controller. Okay, so this is a concept. Okay, so choose the motor. So how much power required to move your vehicle? So we can get the known the power. So for the power we can choose the motor. So from the motor data you have to choose the controller and the battery. Okay, so now we can design the motor for 1.2 kilowatt power. So for 1.2 kilowatt power data from the Google sheet or which company motor you have to buy means data sheet also available. Okay, so which company how to buy the means data sheet also available. So how to enter the name of our motor. So voltage 48 volt. So rated power 1200 watts. So rated speed also available 3000 rpm. So maximum torque so 20 newton per meter. Okay, so we already know. So power equal to torque into omega. Okay, so omega equal to 2 into pi into rpm by 60. Okay, so 2 into pi value 314. So rpm value 3000. So divided by 60, we can get the omega. So value we can find means, so how to find the from RPM. So how much radian we can generate the values. Okay, that way we can substitute. Okay, P equal to T into omega. So omega equal to 2 pi n divided by 60. N is nothing but RPM. So divided by 60. So we have to find the per second value. So 314 is the maximum value produced by your motor. Okay, so the motor deliver maximum torque is 314.519 radian per second. Okay, now the vehicle driven by the motor by using gear. Okay, so already I'm tell, so using gear means you have one formula. So omega equal to velocity by radius into gear ratio. Okay, so formula converted into P into T, torque into V by R into G. So for that we have to substitute. So P equal to, we already know the torque value. Okay, I already know the torque value 20. We don't know the V. Okay, so radius of the V is 0.3. So gearbox ratio is 9 is to 1. So 9 is to 1 gearbox is nothing but, so 9 gear rotate in one direction, 1 gear is rotated in opposite direction. So 9 is to 1. So gearbox available in 6 is to 1, 8 is to 1, 9 is to 1, 11 is to 1, and 12 is to 1. So the types of gearbox. But I choose the 9 is to 1 gearbox. Okay, so I will substitute the 9. So P equal to T into V into 9 by 0.3. Okay, because of we have to know the V, we have to find the V. Okay, so for substitute we can get the V equal to 2 meter per second. That means my use this motor when vehicle 0 to some speed. I don't know what is the maximum speed, but we have what to assume means when a vehicle 0 to some speed, it will be moved in 2 meter per second. Okay, 2 seconds. When a vehicle time is 2 seconds, by use this motor, the vehicle moved in 0 position to some speed with 2 milliseconds, 2 meter per second. Okay, to 2 meter per second. So the motor critical velocity is 2 meter per second. Okay, so now initial acceleration assume T equal to T max. Okay, so now we assume T equal to T max. So here the efficiency. Okay, so here the efficiency G by R into T max. So this formula comes from acceleration. Okay, so because of all values I know, just you can substitute, so convert into equation 1. Okay, so step by step I tell how to convert. So this is efficiency formula. So efficiency NQ, G gear ratio, R tire radius, T max. So this formulas come from rolling resistance. So aerodynamic drag is angular acceleration formula. Okay, we can substitute the angular acceleration formula. We can get the 320 here. Okay, we can just substitute the values. So now simplify that. So how simplify means we can just multiply and divide this value. So I can get 354. Here the multiply this value 35.7. We can just simplify means 0.14 v square. So this 320. Okay, so now time. So 535. So 35 goes to this side means minus 35. So 534 minus 35. So get 498. Get 498. Okay, so similarly you have to find the dv by dt. So next we can go to the this side means minus. Okay, so 498 to minus 0.15 v square, because we got minus, so v is there, so we know not to minus the 498. So next is how to come to 320 this side. So this multiply come to this side means divided. So divided by 498, I get the value 1.557. So divided by 0.14 means I get the values 0.045 v square. So this is for T max, so 20. Okay, so next we have to find the dynamic equations. Okay, for dynamic means how much maximum torque produced by your motor. So same formula. This time we have to find out the torque and velocity, because of we don't know the velocity, so we have to velocity is constant, but we have to find the torque. So we can simplify in same manner. Okay, we can get the 40 by V Newton meter. So the same value we have to apply in the formula. So 40 by V, now we can simplify in same manner. Okay, 40 by V we can now simplify into same manner. Okay, so dv by dt. So get the value means dv by dt 3.3 by v. So 0.1150. So 0.4552 number 2. So now we have the two equations. So for the two equation, we have to find the critical velocity. So in our courses, so we have the electric vehicle master class for 30 days. In this class, we have the programs. Okay, so we can substitute the program means you can get the values. You can get the values. Okay, so for the values, you can find out the critical velocity of this equation. Okay, so that equation values come from 13. So okay, we can substitute two value means the values come from 13 second. Okay, when a vehicle 0 to 90, okay, 0 to 90, my vehicle reach in 13 second. Okay, 13 second I reached the 0 to 90 kilometer per hour for using this motor. Using 1.2 kilometer, my vehicle reached the 0 to 90 within 30 second. Okay, take time 30 second, 0 to 90. Okay, so now you have to calculate the how much total power required to drive your vehicle. Okay, so 5 to 10% of lean axle angle action, so I will neglect it. So the power work done by the period of time. So P equal to W by T. Okay, so W equal to half into mv square. Okay, now the final acceleration value of the vehicle is power equal to half into mv square by t. So we know the time. So because of on the equation simplify 1 and 2, we can get the values 13. Okay, so now substitute. So half into mass of the vehicle 2 and 280. So velocity. So 90 by 3.6 whole square by 13. I can simplify means so total power is 6730 watts. That means 6 kilowatt battery. 6730 watts. You have to choose the battery for 6 kilowatt battery. Okay, for run your vehicle, you have to choose the 6 kilowatt battery. Okay, so these are all the another methods. Okay, so vehicle dynamics topic is completed. You have any doubts in vehicle dynamic topics? In vehicle dynamics topics, you have any doubts? Okay, so you want to know about more EV means you have to join the master class. Okay, so if you want means free to ask. So 30 days master class. In the master class, we have to explain about controller batteries, so how they work. So fabricated video, so connections video, controllers video, all are you can give it in video. So and also how to the EV vehicle fabrication videos. Okay, all available in YouTube channel. You have to complete the class. Have to check it. If you want the courses means you have to join also learn about the EV concepts. Okay, I complete the only one topic basics. So how to before going to the design. So before going to the production, you have to clarify this concept. Okay, that is only the concept. So why we can calculate the vehicle dynamics? I have shown in MATLAB. Once again, I'm opening MATLAB. Please asking in English. Opening MATLAB. Have any doubt in vehicle dynamics and electric vehicles? If any doubt means please ask.